Here's another example on how dimensional analysis might be used. Let's say we started with this equation. Delta x equals v0t plus 1/2 at squared. Looks familiar, doesn't it? This time, let's say you were looking for v0. In other words, you wanted to solve this equation for v0 because you had information about all the other terms. So let's say this is what you got when you solved this equation for v0. Let's say v0 is delta x over t minus 1/2 at squared. And you keep looking at it and you're not quite sure if it's correct. One way to see if it might be correct is to perform a dimensional analysis. Now, from the previous problem, we do know all the dimensions of each term. So let's see if this equation might be correct. So we're going to sub in from the previous example. v0 is L divided by t. Is it equal to delta x L divided by t minus 1/2 times L over t squared times t squared? Time to shrink it down. L over t, does it equal L over t minus 1/2 L over t squared times t squared is 1/2 L. Now really, like before, the 1/2 doesn't mean anything. So we have L over t, is it equal to L over t minus L? It is not. The only way you can have L over t on this side is if you had two L over t terms on the right side. You can't subtract an L from an L over t. So this says this is not consistent. Therefore, you made a mistake in solving and you have to go back and try to solve it properly.